This is the first video to section 6.1, where we'll be briefly doing an introduction to chapter 6. Notice you will have more detailed information in the lecture video. Earlier in the course, we discussed discrete data and continuous data. Please recall that discrete data could be counted, whereas continuous data was often measured. In chapter 4, when we were discussing discrete random variables, we used the binomial distribution. But now in chapter 6, we will be discussing continuous random variables, and we will use the normal distribution for this. It's important that you understand that the graph of a continuous probability distribution is a curve, and the area under the curve is measured using a cumulative distribution function, a CDF, which you will be looking for on your graphing calculator. As you listen to the lecture videos for chapter 6, you will learn about a few things. Please keep in mind that the entire area under the curve above the x-axis is equal to 1. Probability is found for intervals of x values rather than for individual x values. When you see notation like this, or sometimes like this, it represents the probability that the random variable is in the interval between C and D, or the area under the curve above the x-axis is to the right of C but to the left of D. The probability that x will take on a single individual value is 0, and in this case, for a continuous random variable, these two are equal. Again, we'll discuss this more in the lecture videos, so make sure you check those out. Moving on to the second page of our introduction, the normal distribution. This is probably one of the most important types of distributions. The graph of the normal distribution is a curve that is bell-shaped. We have two parameters, the mean and the standard deviation. The curve is symmetric about a vertical line drawn through the mean. And in theory, the mean is the same as the median in this case because the graph is symmetric about our population mean. A change in our standard deviation will either fatten the curve or make it skinnier, all depending on our standard deviation. And a change in the mean will cause the graph to shift to the left and the right. In a continuous random variable, we use a normal distribution. Back in chapter 4, we used a binomial distribution, but here we'll use a normal distribution. This is read as x as a random variable with a normal distribution with a mean and a standard deviation. That's the end of the first video for section 6.1.